Thank you everyone for joining us today for Theorem's webinar series. Today our topic will be how to automate your API security program without the staff. Before we get started, I just want to give a little background on Theorem. The company was founded in 2013 out of the heart of Silicon Valley, headquartered in Palo Alto, California, with offices now in Paris and in New York. Our leadership team has over 15 years in cybersecurity, has published over 6 security research books, and led over $4 billion in security acquisitions. That has led us to have a tremendous amount of success and the privilege to work with a number of great customers, as you can see here, for both their mobile AppSec programs as well as their API security programs. Now, before I turn it over to our speaker, I just wanted to make a couple notes. We will be recording today's session and making that available after the fact, if you can't stay the whole time. And then also, we will reserve some time at the end of the presentation for Q&A. So if there are any questions, please feel free to use the Q&A panel within the event, and we will make sure to answer those questions at the end. With that, I'm going to turn it over to Doug Dooley, the COO of Theorem, who will be presenting today. Doug?
All right. Thanks, Richard. Hi, folks. We're going to walk through some of the agenda items for today's topic, and hopefully we're going to learn something new. The first thing we're going to cover is a review of the API economy and some of the interesting data trends that are happening with APIs. We're going to talk about the problems with securing modern APIs and some of the limitations that exist with traditional solutions that have been tried that have not worked as well. And then we're going to propose an API security framework as a solution. And this API security framework isn't just invented by Theorem, but really lessons learned from customers through operational experience and some of the best customers who've both had some hard lessons and some positive learnings. And last, we'll talk about the benefits that when you successfully automate this framework, this API security framework, some of the benefits you'll get from that. And we'll have some closing recap and sort of next step actions. So let's start with the API economy. If you see this is a visualization of built around the API economy, and there's some very large providers like Google and Microsoft and Facebook and LinkedIn, and a variety of companies, and even Amazon, who really drive a lot of this interconnected world that we live in with APIs. But it's really around data. And so let's look at some of the data that we've learned about the API economy. The first one is really around the growth of public APIs. It's really starting sort of an inflection point in 2011, 2012. You really started to see a pickup of just the sheer number of APIs that are internet accessible. And as a result, most of this data is secured through a mechanism like authentication. But to date, looking at companies who track all the public APIs authentication methods, there are sort of 12 known methods. So it's pretty well understood on how to secure APIs, yet we'll come back to this when we see some of the data with regards to breaches that have occurred as a result of a lack of API security. And then what's really fueling API growth, number one, is mobile applications. By far, the growth of mobile applications that sort of originally were triggered by companies selling to consumers and accessing consumers, but even in the enterprise, even business-to-business companies are much more committed to mobile first and a mobile application experience. And you're seeing here some data sourced by our own analyzer engine. We can tell that among the top mobile applications, there are 6 to 12 API domains typically for most mobile applications. And at the domain level, that's a more coarse-grained level. If you actually look at APIs inside the domains, it's even larger. And then if we look at another source here around who are the top providers around these public APIs, it heavily tracks to SDKs. There's typically a one-to-one relationship between an SDK and a back-end API. And so just the explosion of software development, leveraging third-party open source code and things like SDKs, it continues to drive fuel to API growth. Another thing that's also driving API growth is this commitment and focus on microservices and technologies like serverless. It's really making the cost and the rate of speed to build new applications substantially lower. Microservices is really about chunking up smaller pieces of code for reusability and having that microservice interconnect to other microservices all through APIs. And serverless, similarly, one of the barriers to entry is to build applications and publish and ship applications has been historically the amount of complexity that exists in a data center or managing and running a data center, whether it's storage or network or security or compute. Serverless makes many of these things become much easier, heavily driven by the three of the major cloud providers, Amazon, Microsoft, and Google. And just to take it one step further, even though containers, like virtual containers like Docker, have been something very useful in making application portability easier and interoperability much easier, even though Docker has had incredible amount of growth over the last 10 years, the rate at which serverless adoption is happening is at least twice as fast as what we've seen with something like container technology. And so this really fast adoption is ultimately about driving down cost, increasing simplicity, and making it much easier for a business to publish an application and monetize their data. And so ultimately, if you give a business person 3 wishes, particularly when they're leveraging software, these are the classic 3 wishes they wish they had. You know, reaching your customers better, further, increasing revenue, and making innovation happen much faster or more. And as a result, if you see it, the mobile application experience combined with sort of a modern web application experience is really sort of the crux or the interface at which these 3 wishes come true. But behind the scenes, it's the APIs that interconnect all of it, whether it's third-party SDKs, open source, the back-end system, all of it is interconnected, all the data flows through these APIs, and increasingly these APIs live and exist open on the internet or accessible via the internet versus being in sort of a private data center. And so what are the problems with securing this sort of fueled new modern APIs? We'll talk about this one right here. So right before a data breach, you know, an IT security person can often think our data is safe because it's sitting behind our API gateway and firewall. There's been tremendous investment at the network layer to try to secure data, particularly with a perimeter-style approach. And yet, when you look at every month, there is a new major headline of a data breach. And generally, an API, our watermark that we look for is that if a business or an organization loses over 1 million records, it's almost always an API sitting behind the source of how 1 million+ records were stolen or accessed illegally for the company. And these companies have invested incredible amounts in gateways and firewalls. It's not like these companies don't invest in security. They do a lot of investment in security. But the issue is the investment in many ways is the wrong kind of investment for the future of these new kinds of APIs. And if you really do some post-mortem analysis on some of these data breaches, it's almost never a SQL injection or a fuzzing or cross-site scripting attack or some type of extremely exotic zero-day. I mean, this is, as security people, we're guilty of going to these more exotic, technically interesting attack vectors, but yet what the data is teaching us, it's sort of blocking and tackling security hygiene that's very difficult to do at this massive growth and scale and these changes that are happening all the time. So really lack of authentication, authorization rules, the proper types of end-to-end encryption, these are typically the things to blame at what triggered these major data leaks. And so when you look at the traditional tools, the tools that many of us in security have been growing up with for the last 15, 10 years, you see the focus has always been around having on-premise applications that were built using a waterfall-style process, which means you're making 3 major changes a year, doing some maintenance releases on a monthly basis, and having a concept of a trust or untrust perimeter, right? Having gateway technology or proxy technology at the egress points of where your data could leave and go onto the internet. This is not built in the cloud. It wasn't built for the speed of Agile and DevOps. And so this is many of the traditional approaches which have caused some of the problems here. And so when you think about gateways, particularly API gateways, these things are hammers. And it doesn't mean that this tool doesn't work. It works when it's applied to the right situation. And so if your situation is you have a local area network of your classic on-premise data center, and then you have a choke point, an egress point, where you can layer on firewall technologies at the network application layer, and then layer on a gateway to do things like authentication and encryption, then this seems like a fine architecture. And this is an architecture many of us have grown up with for the last 15 to 10 years. The issue is when you move to a more modern approach, embracing things like cloud and microservices, which mobile and modern web has grown up in, there are far too many nails. This concept of an egress perimeter point where you can choke all the data through an API, it just sort of doesn't make sense. And you could potentially try to do it, and don't get me wrong, there'll be many API gateway vendors that will love to sell you, orders of magnitude, many more gateways. But the issue comes down to scale and complexity. Can you really do this at the type of scale without so much complexity in order to have this type of approach? So our view is, look, going back to this visualization of the API economy, if we had to stick a network-centric appliance device for all these interconnection points, the level of complexity and scale that security would layer on to this environment would be tough. The focus should not be about that type of technology that has worked for us in the past. The focus should be around the pillars of security that matter: authentication, authorization, availability, encryption. These are the 4 pillars that work, that consistently work, and keep customers out of trouble. And when you move to this API-centric world with lots of microservices, this is where customers have focused and have had success. Now, step 1, we're going to propose here a 4-step framework. And this framework, again, was not invented by Data Theorem, but we have learned this from our very capable customers who've done this well at scale. So the first one is specification. You have to, you often don't know what you don't know when it comes to these new APIs. And so having ability to go and interrogate and discover inside the cloud. So whether it's Amazon, Google, Microsoft, you need cloud analyzers to go and continuously discover when API changes are occurring and new APIs are being published. Likewise, you have traditional gateways. Those gateways still have value, and so being able to hook when a new published API or change of an API happens on a gateway, whether that's Apigee or MuleSoft, there's a variety of companies who have gateways. Log analysis. So sometimes tracking whether API transactions are occurring will often show up in your logs, but there's also public logs like certificate transparency logs that you would want to analyze. The moment on your domains, the domains that you own, a subdomain has been registered for a new certificate, that's an early signal that someone might be building a new web application, a mobile application, or publishing a new API. And at that point, there needs to be a deeper level of discovery and analysis of if new APIs are being put up on the internet. Of course, mobile applications. We just talked about it. It's one of the number one ways API has been fueled with growth. Every time you publish a new mobile app, there's typically a dozen or so APIs. Half of them belong to your company, half of them belong to third parties, typically driven through SDKs. And then the same thing would be true for a modern web application like SPAs. A single-page application in many ways is similar to mobile, but for web, it's sort of a heavyweight modern app that does lots of API calls. And then the last, of course, is source code. If you're willing to look at the source code analysis and see at the point where potentially a developer is taking advantage of a new API, that's another early signal that an API is being happening. So from all of this analysis, this discovery process that continuously needs to happen, you sort of come up with a state of the union of what are all your APIs that exist, that come back or attached to your business. So that's sort of the API specification. And typically you want to have this in sort of a Swagger or OpenAPI v3 spec. So you have sort of a standard space so that many people can read it and make sense of it. Sort of step 2 is really about the analysis. So going back to the 4 pillars in security around authentication, authorization, availability, and encryption, that has to happen. It has to constantly be checked for to know, like, even though the spec may say this level of authentication should be occurring, you still need to go and check that what the spec says is actually being implemented in production operation. The other thing that's also really interesting is the kinds of data sources and the kinds of essentially data sources that are attached to that API. You could have incredible insight of discovering an API and the security tools around that API, but really the other piece of insight a security team has to have is what types of data flow through that API. And so that's oftentimes like what kind of storage, what kind of databases are used, and also what kind of architecture is being used. An example that security has grown up with is installing agents on operating systems and basically going through certified operating systems. The moment the infrastructure becomes ephemeral with things like Lambda and Cloud Functions, then the whole security model of what you used to trust starts to change. And so having that insight is also critical, that if an API is using a Lambda function, some of your insight might change in order to think through what do you want to do here. On step 3, this is really where the combination of technical insight and business insight needs to happen. So a business typically builds an application or produces an API even as a product to monetize and mobilize their data. And so that's sort of the business aspect of it. But the technical aspect is all these things that we're showing here, like where are these APIs being built, how are they changing, what level of security is being implemented, and enforced, and then of course what kind of data is going through it. And so that technical insight combined with the business insight allows your security team to really get into a risk management conversation. And then from that risk management conversation, you can start to build your policies and put forth a standard around enforcing policies. And then sort of the last step is this part we talk about, like alerts and remediation, right? Step 4 is when problems are found, notifications have to go out, and in some situations, you'll want to remediate. Now, the first step might be a manual remediation, but ultimately you want to go to an auto remediation whenever possible. Classic example that we see happen all the time, many of these data breaches could have been avoided if you found out that an API has changed or a new data source has been added to that API. So that's sort of on the discovery phase. And then on the analysis side, you realize somebody has disabled token authentication on that API. It was probably, a developer had a reason for doing it in staging and test, but unfortunately because of the DevOps cycle, it moves so fast, it leaked out into production. And at that point, it might be a very simple auto remediation fix that the moment an API that used to have authentication has been removed or disabled, you could auto remediate and turn authentication back on. So this is an example of steps 1, 2, 3, and 4 using sort of a framework, and again, successfully implemented by some of our customers. So our answer, though, for steps 1, 2, and 4 is you have to automate. It's the only scalable approach to be able to do steps 1, 2, and 4. And so our proposal is you need to use an analyzer engine, but anything that can automate steps 1, 2, and 4 matter a lot. And so when we go back and look at sort of an automated API security framework, we happen to have a few products like API Discover and API Inspect, but really the place where your staff needs to focus is in this middle part, around this risk management. That is a part that's very difficult to outsource to automation, but this is where humans talking to other business teams, their people, having those kinds of conversations make sense around the policy enablement and how do you want to go about enforcing that policy. But all of the other pieces around the API security framework, you have to strive for automation. It's the only way to scale, particularly in agile DevOps environments. And so in the end, right, the ideal end state here is to get to this place where the DevOps teams are always going to continue to work in this highly automated fashion. DevOps grew up with automation. So did mobile. So did the modern web. And so when you think of these kinds of environments with this kind of application cycle, security needs to step up and have that automated approach as well in order to be embraced by this high-moving DevOps cycle. And if you do it right, the amount of staff that you need is actually fairly small. We've seen companies with really small security staffs be able to execute this and pull this off with success. And if you want to learn more on how you could do it, at least with Data Theorem, we'd be happy to show you a demo, particularly using your applications in your cloud environments. So with that, we can move to Q&A.
Yeah, thank you very much, Doug. So we do have a few questions. Let me give you the first one. So the first one is, how many employees are typically needed to set up this type of API automation and the ongoing support thereafter?
Well, ongoing support, once you have it all set up, we've seen a half a person. So not even a full-time dedicated person can pull this off. For the initial setup, typically, customers want to make sure all the automation is working the way they expect it to. So they might have someone who's a very DevOps-centric person on the discovery side. They have a more classic security kind of pen tester person on the inspection side. There's a hybrid sort of security policy person for the risk management piece of it, and then there's typically an ops person on remediation. But ultimately, once you have the initial setup and verification done, that 4 or 5 person team reduces down to a half a person, right? And again, we see that happen quite a lot. And ultimately, you want this data, the reporting out of your automated system, to come back to the folks who are driving risk management, and then of course the C levels, the chief information security officers, the CIOs, and the board of directors. They also want to see, like, you've made these investments around protecting the data and protecting things like APIs. Then it's really just sort of a reporting mechanism and making sense of the reports. That's where that half person completely comes in. Again, I'm just sort of speaking in general. Everybody's environment's a little bit different, but I'll be shocked to have teams larger than 5 or more on the setup and 1 for ongoing maintenance.
Perfect. Second question. Automated API security helps with our backend, but what about web apps that can cause a major data breach?
Yeah, so yes, recently APIs have been sort of the main culprit to at least being blamed for these major data breaches. But sometimes it's the web app, sitting in front of that API. And so at least in the case of SPAs, we have some really interesting technology focused on modern web applications and interrogating and discovering and being able to extract out APIs out of modern web applications. And so I think it's an important question, and it's a piece of what needs to be solved for. And the good news is, at least for the data theorem analyzer engine approach, we have support for the cloud, we have support for mobile, and we have support for web applications like SPA.
Perfect. One last question here. How long does it typically take to get an API automation set up?
Well, many of our customers really typically start with the public cloud. So they'll start with their AWS, Azure, Google environment, and you can get that going. I've seen it as fast as 15 minutes. From the initial demo that they take a meeting with us, that person has credentials to a read-only role access, like the security audit role for AWS. We get read-only role access to their Amazon environment. They don't create any accounts for us. They don't create any passwords for us, nothing like that. It's just a standard third-party audit role for read-only, and you can get that up and running in 15 minutes. So we've seen it happen as fast as that. If there's ever a slowdown, it takes more time. It's typically meetings between the cloud team, the DevOps team, and the security team around adding the accounts, adding the role level access. That's what we see, some typical slowdown, but that's not a technical issue. That's more of a, let's call it a process issue. Yeah. Any more questions?
That is all the questions we have. Before we end, I just wanted to let everybody know, if you're interested in continuing the conversation with us, go out to datatheorem.com/demo, and we'd be happy to set up some time to speak with you. And with that, thank you, Doug, for your presentation today, and thank you, everyone, for taking the time to join. All right.
All right. Thank you.